Hello, this is a short demonstration of the features of Brainsight 2. We'll have, I think, 3 videos. The first video will focus on the steps that are performed before your TMS session, so all the preparatory steps of loading images, image processing, picking your target, and so forth. The second video will be an actual TMS session, or a simulated TMS session in this case. And finally, a third video will show the post-TMS session activities where you can analyze the data that you've acquired during your TMS session, looking at the images, looking at the coil positions, EMG data you may have acquired, and how you can use this EMG data to perform motor mapping. So for now, I'll focus on the first steps. So we've already launched Brainsight, and if I click into the File menu and say New Project, here is the area that we call the project window. I'll try to keep this demo down to about 10 minutes. So this project window is where you focus most of your attention. In fact, all the steps that you want to perform before your TMS session are laid out as little icons along the top of this window. Okay. Most of these steps are optional. It largely depends on how you will define your target, and we'll go over these in a few moments. The first step is called anatomical, and that is a compulsory step. In this step, you pick essentially your anatomical images. This area of the project window is a summary of the current step, and as you change steps, this area will change. Now this area is fairly blank right now because we haven't done anything yet in this first step, so I'll just ask you to focus here where it says click here to choose an anatomical data set, and then I click on choose, and I simply navigate to wherever it is on my hard drive I'm keeping my images. So before in fact you got to this step, you will have copied your images over to your hard drive, and you can put them anywhere you like. So you can organize your hard drive and your folders and subfolders however you like. Now, Brainsight supports all the standard file formats, DICOM, PowerRec, Mink, Analyze, Nifty. So you simply pick the format that you're already using in your lab. In this case, since I'm from McGill, we use the Mink file format, so I'm going to just select my MRI here. Now, in fact, I can click on this to show previews, in fact, of the images. So I can scroll through, in fact, this folder, and you can see all the data sets that you have, and then it makes it easier to identify the one you want to use. In this case, it's this one. So now it's loaded. You can see here a little thumbnail of the images. Now, in every step, I can always click on a button of some sort to look at details of a particular step. So in this case, I'll click on Show Image in Details. And that brings up this window, which is a simple viewer. I'll just ask you to focus on the left side of this view for a moment. We have a few buttons. Now these are the tools, and these tools will change depending on what step we're in. So in this case, it's a very simple step. We simply want to look at the images to make sure that they're indeed the right images. In fact, most of the time, if you don't even bother opening this window, but it just gives me a chance to show you some of the tools. So the first tool is a cursor, so essentially I can click and drag the mouse anywhere in the image. This is a sagittal coronal transverse, and this crosshair represents, well, the cursor location. This horizontal line is where the transverse slice is, right? This vertical line is where the coronal slice is, and this vertical line here shows you where the sagittal slice is. We also show the image header down here, so I can look at, in fact, any of the DICOM fields. Again, Brainsight doesn't really care about most of these, but if you look at it, you can see that we read the images in good order. If you saw a bunch of funny characters here, for example, then you'd know that, well, maybe it wasn't read correctly. The only other tool really that's important in this step is a ruler tool. So I click and select this ruler, and I can click and drag anywhere in a 2D view, and we give you the distance in millimeters from the start to the end. And I can grab the end of this ruler, in fact, and move it around. Now we also have an inspector button, this blue eye button. If I click on that, we can manipulate other items, and we'll use this tool more later. But every image view window will have this inspector, it'll have the cursor and the ruler tool, and as we do other steps, more of these tools will appear. So I'm done with that, so I can simply close that window, and we can see here again some random tidbits that were extracted from the image header to make sure that these are correct. Typically, we like to have images that are close to 1 by 1 by 1 millimeters. They don't have to be exactly 1 by 1 by 1 or exactly isotropic, but typically this value or close to that are the optimal voxel sizes for Brainsight. Now the next step is called Atlas Spaces, and this is an optional step, right? So it depends on what you're using to identify your target, or perhaps you might want to export coordinates that you've acquired during your TMS session in an atlas coordinate space. We support both the MNI and Talairac coordinate spaces. So in order to be able to work in the Talairac space or MNI space, we need to be able to know how to map from the subject's native image space to the standard space. And to do that, we need to do a co-registration. Brainsight supports a couple of methods of doing that. If you've got an XFM file, if you're using MIG tools, you can simply click on this and load a matrix that you might have acquired using another imaging tool. So I can say, in this case, I have an XFM file here. Rock to Tal, here we go. So I simply select that file. It's a small little matrix file. And in retrospect, it's not the correct one because now we can look, in fact, and see this is the ICBM 152 average brain, which is our template brain. And we can see that it is not correctly overlaid on the images. Right? So I would not want to use this registration. And here's the matrix that, in fact, we used. So I'm just going to close that, remove that. Now the other method that you might use, you can either load a matrix if you used SPM, and you simply say from matrix, and you would simply type the values in this matrix. So you would have had that matrix printed in a PDF file or on paper, and you would simply type these values in. And as you type that matrix in, this ICBM 152 average brain would overlay correctly on the head. When all that fails, we simply can create a manual registration, and this is what we'll do now. So in order to do a manual registration, we have a couple of steps. The first one is to identify the anterior and posterior commissure. So I simply would move to the anterior commissure. Now, of course, you need to know where those are. I'll say set AC down here, and it drops a marker on the anterior commissure. Now I can find the posterior commissure. Now, of course, I'm an engineer, not a neuroanatomist, so I may not have that perfectly well, but I think this is probably pretty close. And I click on set PC. So these are the two landmarks. These two landmarks allow us to determine the horizontal plane, to line the brain up in a horizontal way. If I click on next step, now we've lined the brain up along the AC-PC plane, which is common to the MNI and Talairac space. Now we simply need to determine the scaling, how we want to stretch or squish the brain to fit the MNI template. So I'm simply moving this box, and I'm not sure if it's very clear in the video, but there's a box here, and we simply want the box to line up to the edge of the brain along the AC, this line here, and vertically along this line here. And in the transverse images, we simply want to line this up here and here. Now, of course, the details of this are available in the user manual. So I'm just going to go through this relatively quickly, just as an example of the features. So once I've done the scaling here, I click on Update. And now we've warped the MNI brain onto my brain. And I can change this to overlay threshold to get rid of this blue hue here. It makes it easier then to see how well it fits. So now I can use this opacity slider to go from the native brain and the warped version of the MNI brain. So if you're familiar with atlas spaces, it's very common, let's say in fMRI analysis, to warp your subject's native brain into the MNI or Talairac spaces for analysis. We require that the brain remain in the original shape since we're trying to co-register this MRI head to the subject's head. So we've done the opposite. We warp the MNI head to fit the subject head. Mathematically, it's the same thing. We can go back and forth. So I'm happy with how this overlays. It's never quite perfect because the MNI brain is a very symmetric brain, being an average of 152 subjects, whereas my brain in this example is somewhat asymmetric, so the fit is never perfect, but that's a limitation of using atlas space images rather than a limitation of Brainsight itself. So when I'm done, I simply click on Finish, and now we just simply have this line in this summary window showing that we've performed an AC-PC box registration. The next step is called overlay. So instead of an atlas coordinate, maybe you have an fMRI data set that you want to overlay. Maybe you perform a specific task of some sort, and you'd like to overlay that task onto the anatomical images and use that to pick your target. So I'll click simply on Configure Overlays, and it brings up this new window. And so here we have, again, the anatomical images, and I can go to the HUD here, and I can adjust in 3D the zoom. I can change the orientation of the images. Of course, I can click and drag to rotate as well. And in the 2D images, I can bring up this heads-up display or HUD, and change the zoom factor as well. Now you can't see my finger here, but I can actually option click and drag to either zoom and pan. In the 3D view, it's important to note whenever I click on it, you notice this blue circle appear. In 3D view, we need to interpret your gestures. So when I click and drag, that's a cue to Brainsight that we want to rotate the images. Now rotating is a three-dimensional operation and the mouse is a two-dimensional tool. So we have a little trick. If I click outside the blue circle, the rotation is strictly a twist motion. Right? So if I click in the circle, drag, it rotates in the direction of the mouse movement. If I click outside, it twists. Okay, and that'll be used in subsequent steps as well. So in the overlay, I simply want to click on Add, and I can add an fMRI. Now, the fMRI data would have had to have been co-registered to the anatomical data set before this step, and you would use your favorite fMRI analysis tools, which often will have co-registration tools as well. So in this case, I have a file called fMRI resampled. So the file was resampled to the same orientation and resolution as the anatomical data set. Now, if you're using a nifty data format, it's possible for your software to embed the registration matrix in the image data set, so you would not need to reslice it. The matrix would simply be applied much in the same way that we apply matrix to co-register it to MNI space. So here is an overlay of our fMRI data, and we now have a threshold control here, so I can drag either the upper and lower threshold to reduce or remove the superfluous data. So I'm just going to slide the lower threshold to 5, which is a typical t-stat value of significance. And now we can see in the view here we have some fMRI data being shown. Right? And we'll use that in future steps to try and pick a target. You can add as many overlays as you like, and then once you've added more than one, you can reorder them simply by dragging this before or after other ones. In case there's an overlap, you can control how the overlap so that the last one will be the one that's drawn on top. You can also change the opacity, so I can make it very translucent or very opaque. Alright, so we'll go to the next step. The next step, in fact, we're going to skip quickly. It's simply called an ROI tool. A lot of people who use Brainsight use it for other purposes, and sometimes they wish to just paint a region of the brain. So we've included some basic painting tools. So if I turn this off for a second, I can simply select a pencil tool and trace a region. So if I want to highlight the region for some particular reason, I can then fill it and go to the next slice and repeat that. So it's kind of a tedious drawing tool, but there's some purposes for that. We're hoping in the future to add perhaps some diffusion imaging or diffusion processing tools in Brainsight. And one of the first things that you would require for that is an ROI tool to paint the regions that you wish to analyze. You can also use it to segment certain areas. Now, instead of simply painting it manually, if you can isolate the region you're interested in using intensities, I can use this threshold tool to try to highlight a certain region. So, for example, if I change this to transverse, I can usually highlight a section of the brain here, right? So I can play with the upper and lower thresholds, try to isolate the region I'm interested in. And if I can, then I can use this tool here called a seed tool. And simply drop a seed. I drop a seed, it's much like a paint bucket tool in Photoshop or some other painting program where it will paint the region that's connected, in this case connected by the highlighted purple boxes. Now I can click on next slice, and the seed will follow me to the next slice and reapply itself. So I can, in a semi-automatic way, segment a region of the brain. So I'm just going to zip through this section here. And of course, at any time, I can use the pencil tool to make an adjustment, the fill tool to fill it in, or I can use this eraser tool to correct it, right? But normally, you would not need to use this tool. And you can call it, of course, you will. Right. Now, the next step is a compulsory step. So atlas spaces, overlays, and ROIs are optional steps, and these will depend on what you want to use as a target aid. The next step is called reconstructions, and we do need 2 reconstructions here. So everything we've looked at so far are 2-dimensional images. If I click on New here now and select New Skin, we have an automatic tool to create a new skin object. And I'm simply going to click on Compute Skin. You can change the color, you can rename it. However, I think we prefer that you call this object Skin because we make some assumptions later. So we've created now a skin based on the MRI images. Right? So now I can zoom up on this and you can look at different features. We'll be looking at the ears and the face in a future step to identify landmarks for co-registration. Let me zoom back out. Now, some people don't like the fact that this looks a little messy, and that's because my head was exiting the head coil and we have a signal drop, and that signal drop then looks kind of, well, icky. So we introduce a new tool here. So we have the cursor tool, the ruler tool, and now we have the crop tool. I can click on this tool, and I'll click on the skin, and you notice now that there's a box, and there are these little handles for each face of the box. So if I grab a handle, I can click and drag it wherever I want. And when I let go, anything outside of this new box position gets cropped. Okay, so I can change that anytime I want. Okay. And I come back to the cursor tool. And this tool is available now for in future steps, so you can crop this as you like and anytime you like down the road. Now we've done the skin. We also like to have a 3D brain. Now, Brainsight has a unique 3D reconstruction tool called curve linear reconstruction. We in fact originally developed this about almost 15 years ago for epilepsy visualization. So instead of doing a 3D surface reconstruction, much like you would for the skin, and this is, in fact, the 3D brains are often displayed as 3D surfaces. In TMS, we're not interested in just the brain surface, we're interested in what's called the cortical ribbon, which is roughly that 1.5 centimeters of cortex from the surface of the brain down. Now, in order to have a nice 3D rendering of that, we have what's called a curve linear. So what we've done is we've automatically extracted roughly the dura of the brain and created a surface. Instead of giving it some arbitrary color, we're in fact painting it with the gray values from the MRI itself. And here we have a peel depth slider, so I can actually now selectively peel down, right, from 0, the reference depth, to different depths here. Right? Now if I zoom up on a region of the cortex here, so let's say we're interested in the motor strip. I can peel to different depths, and here, in fact, it's hard to see what's the motor strip, but if I peel down, I can see now a very nice contiguous motor strip, right? Starting up here, the foot area, the trunk, and then the hand area, and so forth, right? You can see sensor behind, so you can get a really good appreciation of the anatomy. Now, if I go back to the inspector here and click on the Overlays tab, I can turn the overlay back on, and here's the fMRI data set. So now we can overlay the fMRI data on the curve linear brain. And what's really nice is now that I peel, I can see exactly where the fMRI data is. A lot of fMRI visualization tools will project the fMRI data onto the cortical surface for the purposes of display, because if you're looking at just the surface and the fMRI is behind it, you're not going to see the data. So you project it on the surface and paint that. But of course, once you've done that, you've actually physically moved where your fMRI peak occurred. If you're trying to hit it with a TMS coil, then you're no longer aiming at the correct target. The curve linear display allows us to leave the fMRI data where it was measured, and we can simply cut down to go find it. Right? So we could find it, of course, in a 2D view. Right? If I look here, there's a peak there, right? So, but that took a bit of hunting and looking at several slices, whereas looking at the curve linear display, it's very easy to go, boom, right there, there's our hot spot. So that's what the curve linear brain gives us. Now, of course, if you want to go old school, because I did an ROI in the previous step, I can select a new surface from ROI. And I can ask it to create a surface. So I've painted this little slab of brain, and here's a 3D surface, much like a traditional brain surface. So if I had painted that whole brain, it would have taken a few minutes, but once I would have done that, I could generate the 3D brain this way. But the curve linear, being automatic, is usually a much better tool. Now the next step is called landmarks. So we need to identify some landmarks in the subject's head. And that's to allow us to co-register the head to the images. So the way we co-register in Brainsight is by identifying some landmarks on the face, usually the ears and the nose. And during the TMS session, you'll be asked to touch the same points on the subject's head. And that way the system will then calculate how to go from the lab space to the image space. Right? So if I click on Configure Landmarks, now we typically pick as good landmarks the Bayesian, right? So the idea is we need to pick some unambiguous and fairly rigid landmarks. So if I zoom up quickly here, there's a Bayesian. Now if I click on the nose, so instead of clicking and dragging, if I just click, the cursor moves to that location. Right? So if I click here, I can also look in the 2D views to make sure that it looks correct. And I click on New to record the landmark. And I'll call this Nasian. You can give it anything you like, but the computer will eventually read those out verbally during the TMS session. Now the next point is the tip of the nose, and that's only really if it's not been clipped by the scan. It's, despite being soft, it's actually fairly rigid. Even if I make different faces, it tends not to move, so we found it to be a pretty reliable landmark. And I'll click New and call it tip of nose. Now we want to try and surround the head with some landmarks, so what I'll do now is if I rotate around to the left here and zoom in. Now there's a few landmarks we want to pick here. Now we want to be careful. An obvious landmark would be the tragus, right? The tragus here is a very unambiguous landmark. However, during an MRI scan, you might be wearing earplugs, and therefore the ear tragus might be distorted. So we normally would use instead the supratracheal notch just above the tragus. You can see quite clearly there's a line here, right? If I zoom in here, this notch right there. So if I click right here in the posterior lip of that, that's a nice unambiguous landmark. You can see it quite clearly here. There's a little inverted V. That'll be a good landmark. So I click on that, and I can say left ear. Now, some labs, you have big earplugs or earphones, and they instead would use this point here at the bottom of the ear. That's also a fairly rigid, not quite as rigid, but a pretty decent landmark as well. Now we zoom out, rotate around, we'll zoom into the ear, and select that one. And click on that and say right here. And I'll close that window. So we've done our landmarks for the registration. Now the last step before your TMS session is to pick your target. So if I click on targets and configure targets, now you can define your targets in many ways. I'm just going to change this layout for the video so we can see at least one big 3D view here. Right? So I'm going to click on curve linear. So you notice that in the previous step, in the landmarks registration, the skin was automatically in the window. I didn't have to tell Brainsight, I need to see the skin, I need to see these transverse coronal and sagittal images. We know that, so the default display is set to be laid out in a way that's we think to be optimal for performing that particular step. Of course, you can change the layout anytime you like. You can change what we're displaying to display whatever it is you're interested in seeing. Okay. So here's the curvilinear brain, and again I can turn the overlay back on if I choose. If, let's say, this is how I want to define my target, I can simply now look at the fMRI and click here. When I click on the brain, notice now we have a little TMS coil, and we have this cone. Now the cone is to give you an idea of the orientation of the coil. So in fact, you can define a target using two methods. One, you can pick what we call a trajectory, so a position on the cortex and the preferred approach angle for the coil. Or you can simply put a point either on the cortex or on the scalp, not worry about the angles now, and record it as a marker. The idea there is we assume that during the TMS session you'll worry about getting the orientation correct. We'll assume right now that you want to do the orientation in Brainsight. So when I clicked here, we knew the curvature of the cortex here. We have these oblique views, so inline, and let me put the inline 90 there, and perpendicular. So these are three views that are locked to the orientation of the coil. So think of a plane this way as being inline, a plane this way as being inline 90, and perpendicular being the image that's in the face of the coil's plane. Okay. So now I have these three sliders here called AP, lateral, and twist. If I slide the AP slider, we're tilting the coil forward and backward. Right? So if you look at the 3D view here, right? Now we can also see how that affects, oops, let me turn this to inline, say inline 90. As I change an angle, watch how the inline changes. Right? So we're actually more interested in making sure that the coil is somewhat flat on the scalp, because that's usually what marks a good trajectory, right? So you want to be as close to the target as possible, flat on the scalp so the coil sits nice and flat. And I want to set the orientation in a lateral sense to make sure that we're nice and flat here, right? So that gives us a decent orientation here. Now, if you notice, it's not necessarily perfectly perpendicular to the cortex, and that's because in this case, the cortex isn't perfectly parallel to my scalp. The bone is thinner here than it is here, so it's almost like acting as a bit of a wedge. So it's important to take that into consideration when picking your trajectory. Now the last angle we're interested in is the twist, right? So I can twist the coil about its axis. So in this case, if we think of the literature, motor strip, they tend to want to be at 45 degrees. So now I'm happy with my target. I can simply say new trajectory, and it drops, this other way now, a stick with an origin where the cursor happened to be at that time. Now I can rename that, so trajectory, I can call it 1 or motor M1, whatever you like. I can change the size of the object, both in the 3D and 2D, so I can make it a bigger X or a smaller X, or a bigger stick or a smaller stick. I can also change the shape from a cone to an arrow, right? Or to the old-fashioned Brainsight from Brainsight 1. You can also, if you want, if you had a CAD file, select Other, and then load an STL file from Common CAD software if you want to display it as a unique shape. Garden gnome, if you like. Doesn't Brainsight wouldn't matter. You would simply stick whatever that CAD file is there. Now that's defining your target based visually or on fMRI data. Now you'll notice here we have coordinates in the bottom right of the window, and because I performed an M&I registration earlier, I can click on the brain and see what the M&I coordinates here are, or I can type M&I coordinates directly and the cursor moves to that location. So if I had a target based on M&I coordinates, I could type in the coordinates here, then maybe tweak the angle if I like, and then record that as well. So you can define your target using whatever criteria is important for your experiment. Now, so far we've just been creating single targets. If I move over here, I can, for example, instead create a whole grid of targets. So if I put a marker here, let's say I want to do a search pattern over this part of the motor strip, I can select new rectangular or circular grid. There's a new grid. The grid can be either trajectories or markers, however we recommend to use markers. I can change let me change the size of it. I find these circles to be a little bit busy, so I can make the 3D size smaller, so I can have smaller dots that are in the same location, but I can see more of the cortex underneath it. I can change the size of the grid. I can make it rectangular or a larger square. I can also change the spacing from anything to anything. Right? So 7 by 7, 10 millimeters by 10 millimeters, however you like. Now if I zoom back out again, the grid itself, right, if I select this tool called the Target Position tool, I can now interactively move this grid over my head. I can then optimize the size. Maybe that grid's a bit big. Maybe I can make it smaller, which is good because that means less TMS clicking. I can make sure the grid is exactly covering the area that I'm interested in. Now if you look at the grid, we start as a flat sheet, but I can use this curvature tool now to give it some curvature. So I can try and approximate the shape of the cortex. So the grid will better hug the cortical surface. It's a spherical approximation. However, that's sufficient for most cases. So if I click somewhere else now we have a grid or of individual points or a trajectory. So you can use any of these tools to define as many targets as you like using any method you like. And this is all you need to do before your TMS session. So in fact, this can be done weeks, days, months before your subject arrives. You can do it at your leisure. Take your time and do the analysis and carefully pick your targets. Now we simply would say save project. Again, you can put the project file anywhere you like. However, we recommend that you keep the project in the same folder as your images because it makes it easier to move those from one computer to another without losing the images or losing the project file. And simply click save. Now I have a previous one called training, which I'll just replace. And you can close that window. And that concludes the preparatory steps. The next video will be a mock TMS session, followed by another video for your analysis of your data. Thank you.